Ever wondered what would happen if two colossal solar flares exploded from the sun and Earth was in the firing line? Solar flares, a cosmic phenomenon as fascinating as it is unpredictable. These bright eruptions occur when the sun's magnetic field lines twist and snap, releasing a massive amount of energy into space. Picture the energy of 1 billion atomic bombs exploding at once. That's the scale we're talking about. In the grand cosmic ballet, these flares pirouette and somersault, sending out high-energy particles and radiation across the solar system. They're part of the sun's complex weather system, and just like earthly weather, they can be hard to predict. But why should we care about these space weather events? Well, they're more than just a dazzling light show. These solar tantrums can have significant impacts on our home planet, especially when they're aimed right at us. Now, imagine two of such flares heading straight towards Earth. What do you think might happen? To understand the potential impact, we need to delve into the science behind these solar flares. So, let's take a journey into the fiery core of the sun, where these spectacular eruptions originate. Solar flares are massive explosions that occur on the sun's surface. They're driven by the complex interplay of magnetic fields and plasma, the hot, electrically charged gas that makes up the sun. The sun's magnetic fields are constantly shifting and twisting. When they become too tangled, they can suddenly snap and reform, releasing a staggering amount of energy. This release of energy is what we see as a solar flare. Now, this energy doesn't just stay on the sun, it's hurled out into space as electromagnetic radiation. This radiation spans the entire electromagnetic spectrum, from radio waves through visible light, all the way to high-energy gamma rays. Imagine an enormous slinky stretching between 2 points. If you suddenly let go of one end, the slinky will snap back and vibrate, sending waves down its length. That's similar to how energy travels away from a solar flare. The energy races away from the sun at the speed of light, taking just 8.5 minutes to reach our planet. Solar flares are categorized into 3 types based on the strength of their emitted X-ray radiation. Class C flares are small, with few noticeable consequences here on Earth. Class M flares are medium-sized. They can cause brief radio blackouts at the poles and minor radiation storms. Lastly, the big ones, Class X flares, can have major effects on our planet, causing widespread radio blackouts and long-lasting radiation storms. So in essence, solar flares are a kind of cosmic weather, a storm on the sun with potential impacts far beyond its surface. They illustrate the sun's dynamic nature and remind us that our star, while life-giving, can also be volatile and unpredictable. So we've seen how solar flares are born, but what happens when they reach Earth? That's the question we'll explore in the next scene. Stay tuned as we delve into the fascinating world of space weather and its effects on our planet. Solar flares, especially of this magnitude, can have significant effects on Earth. These celestial fireworks are not just a spectacle to behold, but they carry with them a host of potential impacts on our planet. Our Earth's atmosphere is the first line of defense against these solar emissions, but when the flare is substantial, it can cause disturbances in the atmospheric layer where GPS and communications signals travel. This can lead to signal degradation or even total blackout of satellite communications and navigation systems. Imagine a day without your GPS guiding you or your favorite radio station playing that song you love. That's the power of a solar flare. Moreover, these flares can also induce surges in power grids. The geomagnetic storms caused by solar flares can increase the Earth's magnetic field, leading to enhanced currents in power lines, causing grid systems to overload and potentially collapse. Think about the chaos if a whole city or even a country goes dark. Now let's talk about the folks who are in the most immediate danger from these flares: the astronauts in space and high-altitude travelers. The intense radiation from a solar flare can pose a significant health risk to these individuals, as the Earth's magnetic field, which deflects most of this radiation, weakens with altitude. But it's not all doom and gloom. These solar emissions are also responsible for one of the most breathtaking natural phenomena we can witness: the auroras. When the charged particles from the sun interact with the Earth's magnetic field, they cause the gases in the upper atmosphere to glow, creating the magical light show known as the Northern and Southern Lights. In the face of such immense cosmic power, we truly realize how small we are, yet how significant our understanding and preparation can be. As we continue to study these solar flares, we can better prepare for their impacts, safeguarding our technological society and the explorers among the stars.